I have the great pleasure to announce Joscha, who will give us a great talk with the title The Ghost in the Machine. And he will talk about consciousness of our mind and of computers, and somehow also tell us how we can learn from AI systems about our own brains. And I think this is a very curious question. So please give it up for Joscha.
Good evening. This is the fifth of a talk in a series of talks on how to get from computation to consciousness and to understand our condition in the universe, based on concepts that I mostly learned by looking at artificial intelligence and computation. And it mostly tackles the big philosophical questions: what can I know, what is true, what is truth, who am I, which means the question of epistemology, of ontology, of metaphysics, and philosophy of mind and ethics. And to clear some of the terms that we are using here, what is intelligence, what's a mind, what's a self, what's consciousness, how are mind and consciousness realized in the universe. Intelligence, I think, is the ability to make models. It's not the same thing as being smart, which is the ability to reach your goals, or being wise, which is the ability to pick the right goals. But it's just the ability to make models of things. And you can regulate them later using these models, but you don't have to. And the mind is a thing that observes a universe. A self is an identification with properties and purposes. That's what a thing thinks it is. And then you have consciousness, which is the experience of what it's like to be a thing. And how our mind and consciousness realized in the universe, this is commonly called the mind-body problem. And it's been puzzling philosophers and people of all proclivities for thousands of years. So what's going on? How is it possible that I find myself in a universe and I seem to be experiencing myself in that universe? How does this go together? And what's going on here? The traditional answer to this is called dualism. And the conception of dualism is that, in our culture at least, this dualist idea that you have a physical world and a mental world, and they coexist somehow. And my mind experiences this mental world, and my body can do things in the physical world. And the difficulty with this dualist conception is how do these two planes of existence interact? Because physics is defined as causally closed. Everything that influences things in the physical world is by itself an element of physics. So an alternative is idealism, which says that there is only a mental world, we only exist in a dream, and this dream is being dreamt by a mind on a higher plane of existence. And difficulty with this is very hard to explain that mind of a higher plane of existence. Let's put it there, why is it doing this? And in our culture, the dominant theory is materialism, and this, basically there's only a physical world, nothing else. And the physical world somehow is responsible for the creation of the mental world. It's not quite clear how this happens. And the answer that I am suggesting is functionalism, which means that indeed we exist only in a dream. So these ideas of materialism and idealism are not in opposition, they are complementary, because this dream is being dreamt by a mind on a higher plane of existence, but this higher plane of existence is the physical world. So we are being dreamt in the neocortex of a primate that lives in the physical universe. And the world that we experience is not the physical world, it's a dream generated by the neocortex. The same circuits that make dreams at night make them during the day. We can show this. And we live in this virtual reality being generated in there, and the self is a character in that dream. And it seems to take care of things. It seems to explain what's going on, explains why miracles seem to be possible, why I can look into the future but cannot break the bank somehow. And even though this theory explains this, shouldn't I be more agnostic? And there are not alternatives that I should be considering, maybe the narratives, our big religions, and so on. And I think we should be agnostic. So the first rule of epistemology says that the confidence in a belief must equal the weight of the evidence supporting it. Once you stumble on that rule, you can test all the alternatives and see if one of them is better. And I think what this means is you have to have all the possible beliefs. You should entertain them all, but you should not have any confidence in them. You should shift your confidence around based on the evidence. So, for instance, it is entirely possible that this universe was created by a supernatural being, and it's a big conspiracy, and it actually has meaning, and it cares about us, and our existence here means something. But there is no experiment that can validate this. A guy coming down from a burning, from a burning bush that you've talked to on a mountaintop, that's not a kind of experiment that gives you valid evidence, right? So intelligence is the ability to make models, and intelligence is a property that is beyond the grasp of a single individual. A single individual is not that smart. We cannot figure out even Turing-complete languages all by ourselves. To do this, you need an intellectual tradition that lasts a few hundred years at least. So civilizations have more intelligence than individuals, but individuals often have more intelligence than groups and whole generations. And that's because groups and generations tend to converge on ideas. They have consensus opinions. And very wary of consensus opinions, because you know how hard it is to understand which programming language is the best one for which purpose. There's no proper consensus, and that's a relatively easy problem. So when there's a complex topics and all the experts agree, there are forces at work that are different than the forces that make them search for truth. These consensus-building forces, they're very suspicious to me. And if you want to understand what's true, you have to look for means and motive, and you have to be autonomous in doing this. So individuals typically have better ideas than generations or groups. But as I said, civilizations have more intelligence than individuals. What does a civilizational intellect look like? The civilization intellect is something like a global optimum of the modeling function. It's something that has to be built over thousands of years in an unbroken intellectual tradition. And guess what? This doesn't really exist in human history. Every few hundred years, there's some kind of revolution. Somebody opens the doors to the knowledge factories and gets everybody out and burns down the libraries. And a couple generations later, the knowledge worker drones of the new king realize, oh my God, we need to rebuild this thing, this intellect. And then they create something in its likeness, but they make mistakes in the foundation. So this intellect tends to have scars. Like our civilization intellect has a lot of scars in it that make it hard to difficult to understand concepts like self and consciousness and mind. So the mind is something that observes the universe, and the neurons and neurotransmitters are the substrate in the human intellect. And the working memory is the current binding state. How do the different elements fit together in our mind? And the self is the identification with what we think we are and what we want to happen. And consciousness is the contents of our attention. It makes knowledge available throughout the mind. And civilization intellect is very similar. Society observes the universe. People and resources are the substrate. The generation is the current binding state. And culture is the identification with what we think we are and what we want to happen. And media is the contents of our attention and make knowledge available throughout society. So the culture is basically the self of civilization, and media is its consciousness. How is it possible to model a universe? Let's take a very simple universe, like the Mandelbrot fractal. It can be defined by a little bit of code. It's a very simple thing. You just take a pair of numbers, you square it, you add the same pair of numbers, and you do this infinitely often. And typically, this goes to infinity very fast. And there's a small area around the origin of the number pair, so between -1 and +1 and so on, where you have an area where this converges, where it doesn't go to infinity. And this is where you make black dots, and then you get this famous structure, the Mandelbrot fractal. And it has, because this divergence and convergence of the function can take many loops and circles and so on, a very complicated shape, a very complicated outline. And it's an infinitely complicated outline there. So there's an infinite amount of structure in this fractal. And now imagine you happen to live in this fractal, and you are in a particular place in it, and you don't know where it is, where that place is, and you don't even know the generator function of the whole thing. But you can still predict your neighborhood. So you can see, oh my God, I'm in some kind of spiral, and it turns to the left, and goes to the left, and goes to the left, and becomes smaller. So you can predict. And suddenly it ends. Why does it end? A singularity. Oh, it hits another spiral. So there's the law, when a spiral hits another spiral, it ends, and something else happens. So you look, and then you see, oh, there are certain circumstances where you have, for instance, an even number of spirals hitting each other instead of an odd number, and then you discover another law, and we make like 50 levels of these laws, and this is a good description that locally compresses the universe. So the Mandelbrot fractal is locally compressible. We find local order that predicts the neighborhood if you are inside of that fractal. The global modeling function of the Mandelbrot fractal is very, very easy. It's an interesting question. How difficult is the global modeling function of our universe? Even if we know it, maybe it doesn't help us that much. It will be a big breakthrough for physics when we finally find it. It will be much shorter than the standard model, I suspect. But we still don't know where we are. And this means we need to make a local model of what's happening. So in order to do this, we separate the universe into things. Things are small state spaces and transition functions that tell you how to get from state to state. And if this function is deterministic, it is independent of time. It gives the same result every time you call it. For an indeterministic function, it gives a different result every time, so it doesn't compress well. And causality means that you have several things and they influence each other's evolution through a shared interface, right? So causality is an artifact of describing the universe as separate things, and the universe is not separate things, it's one thing. But we have to describe it as separate things because we cannot observe the whole thing. So what's true? There seems to be a particular way in which the universe seems to be, and that's the ground truth of the universe, and it's inaccessible to us. And what's accessible to us is our own models of the universe, the only thing that we can experience. And this is basically a set of theories that can explain the observations. And truth, in this sense, is a property of language. And there are different languages that we can use, like geometry and natural language and so on. And ways of representing and changing models are languages. And several intellectual traditions have developed their own languages. And this has led to problems. Our civilization basically has as its founding myth this attempt to build this global optimum modeling function. This is a tower that is meant to reach the heavens. And it fell apart because people spoke different languages, the different practitioners in the different fields, and they didn't understand each other, and the whole building collapsed. And this is, in some sense, the origin of our present civilization. And we are trying to mend this and find better languages. So whom can we turn to? We can turn to the mathematicians, maybe, because mathematics is the domain of all languages. Mathematics is really cool when you think about it. It's a universal code library maintained for several centuries in its present form. There is not even version management. It's one version. There's a pretty much unified namespace. They have to use a lot of the Unicode to make it happen. It's ugly, but there you go. Has no central maintainers, not even a code of conduct beyond what you can infer yourself. But there are some problems at the foundations that they discovered. See, can you infer this is good conduct? Georg Cantor, okay, power to you. In 1874, discovered when you looked at the cardinality of a set, that when you described natural numbers using set theory, that the cardinality of a set grows slower than the cardinality of the set of its subset. So if you look at the set of the subsets of a set, it's always larger than the cardinality, the number of members of the set. Clear, right? If you take the infinite set, it has infinitely many members, omega. You take the cardinality of the set of the subsets of the infinite set, it's also an infinite number, but it's a larger one. So it's a number that is larger than the previous omega. Okay, that's fine. Now we have the cardinality of the set of all sets, right? We make the total set, the set where we put all the sets that could possibly exist and put them all together, right? That has also infinitely many members, and it has more than the cardinality of the set of the subsets of the infinite set. That's fine. But now you look at the cardinality of the set of all the subsets of the total sets. The problem is that the total set also contains the set of its subsets, right? It's because it contains all the sets. Now you have a contradiction, because the cardinality of the set of the subsets of the total set is supposed to be larger, and yet it seems to be the same set and not the same set. It's an issue. So mathematicians got puzzled about this, and the philosopher Bertrand Russell said, maybe we just exclude those sets that don't contain themselves, right? We only look at the set of sets that don't contain themselves. Isn't that a solution? Now the problem is, does this set of the sets that doesn't contain themselves contain itself? If it does, it doesn't. If it doesn't, it does. That's an issue. So David Hilbert, who was some kind of a community manager back then, said, guys, fix this. This is an issue. If mathematics crashes, we are in trouble. Please solve meta-mathematics. And people got to work. And a short amount of time, Kurt Gödel, who had looked at this in earnest, said, oh, there's an issue, you know. As soon as we allow these kinds of loops, and we cannot really exclude these loops, then our mathematics crashes. So that's an issue. It's called Unentscheidbarkeit. And then Alan Turing came along a couple years later, and he constructed a computer to make that proof. He basically said, if we build a machine that does these mathematics, and the machine takes infinitely many steps sometimes for making a proof, then we cannot know whether this proof terminates. So it's a similar issue for the Unentscheidbarkeit. That's a big issue, right? So we cannot basically build a machine in mathematics that runs mathematics without crashing. But the good news is, Turing didn't stop working there, and he figured out, together with Alonzo Church, not together independently, but at the same time, that we can build a computational machine that runs all of computation. So computation is a universal thing. And it's almost as good as mathematics. Computation is constructive mathematics, the tiny neglected subset of mathematics where you have to show the money. In order to say that something is true, you have to find that object that is true. You have to actually construct it. So there are no infinities because you cannot construct an infinity. You add things and you have unboundedness maybe, but not infinity. And so this part of computation is the one that can be of mathematics that can be implemented. It's constructive mathematics. It's the good part. And using universal computer is very easy to make, and all universal computers have the same power. That's called the Church-Turing thesis. And even, Turing didn't even stop there. The obvious conclusion is that human minds are probably not in the class of these mathematical machines that even God doesn't know how to build if it has to be done in any language, but it's a computational machine. And this also means that all machines that human minds ever encounter, all mathematics that human minds encounter, will be computational mathematics. So how can we bridge the gap from mathematics to philosophy? Can we find a language that is more powerful than most of the languages that we look in mathematics, which are very narrowly defined language, so every symbol, we know exactly what it means? When we look at the real world, we often don't know what things mean. In our concepts, we're not quite sure what they mean. Like culture is a very vague, ambiguous concept. So what I said is only approximately true there. Can we deal with this conceptual ambiguity? Can we build a programming language for thought where words mean things that are supposed to mean? And this was the project of Ludwig Wittgenstein. He just came back from the war and a lot of thoughts, and then he put these thoughts into a book, which is called the Tractatus. And it's one of the most beautiful books in the philosophy of the 20th century. And it starts with the words, die Welt ist alles, was der Fall ist. Die Welt ist die Gesamtheit der Fakten, nicht der Dinge. Die Welt ist bestimmt bei den Fakten und dadurch, dass diese all die Fakten sind. Und so weiter. This book is about 75 pages long, and it's a single thought. It's not meant to be an argument to convince a philosopher. It's an attempt by a guy who's basically a coder, an AI scientist, to reverse engineer the language of his own thinking and make it deterministic, to make it formal, to make it mean something. And he felt back then that he was successful and had a tremendous impact on philosophy, which is largely devastating because the philosophers didn't know what he was on about. They thought it's about natural language and not about coding. And he wrote this in 1918, so before Alan Turing defined what a computer is. But he could already smell what a computer is. He already knew about the University of Computation. He knew that a NAND gate is sufficient to explain all of Boolean algebra and it's equivalent to other things. So what he basically did was he preempted the logicist program of artificial intelligence, which started much later in the 1950s. And he ran into troubles with it. In the end, he wrote a book, Philosophical Investigations, where he concluded that his project basically failed. And that there is because the world is too complex and too ambiguous to deal with this. And symbolic AI was mostly similar to Wittgenstein's program. So classical AI is symbolic, you analyze a problem, you find an algorithm to solve it. And what we now have in AI is mostly subsymbolic. So we have algorithms that learn the solution of a problem by themselves. And it's tempting to think that the next thing what we have will be meta-learning, where you have algorithms that learn to learn the solution to the problem. Meanwhile, let's look at how we can make models. Information is a discernible difference. It's about change. All information is about change. The information that is not about change, you cannot see a causal effect in the world because it stays the same, right? And the meaning of information is its relationship to change in other information. So if you see a blip on your retina, the meaning of that blip on your retina is the relationships you discover to other blips on your retina. It could be, for instance, if you see a sequence of such blips that are adjacent to each other, first order model, you see a moving dust mote or moving dot on your retina. And a higher order model makes it possible to understand, oh, it's part of something larger. There's people moving in a three-dimensional room and they exchange ideas. And this is maybe the best model you end up with. That's the local compression that you can make of your universe based on correlating blips on your retina. And for those blips where you don't find a relationship, which is a function that your brain can compute, they are noise. And there's a lot of noise in our retina too. So what's a function? A function is basically a gearbox. It has n input levers and one output lever. And when you move the input levers, they translate to a movement to of the output levers, right? And a function can be realized in many ways. Maybe you cannot open the gearbox. And what happened in this function could be, for instance, two sprockets which do this. Or you can have the same results with levers and pulleys. And so you don't know what's inside, but you can express it as this does 2 times the input value, right? And you can have a more difficult case where you have several input values and they all influence the output value. So how do you figure it out? A way to do this is you only move one input value at a time and you wiggle it a little bit at every position and see how much this translates into wiggling of the output value. And this is what we call taking partial differential. And it's simple to do this for this case where you just have multiplied by 2, and a bad case is like this. You have a combination log, and it has maybe a 1,000-bit input value, and only if you have exactly the right combination of the input bits, you have a movement of the output bit. And you're not going to figure this out until your CERN burns out, right? So there's no way you can decipher this function. And the functions that we can model are somewhere in between, something like this. So you have 40 million input images, and you want to find out whether one of these images displays a cat or a dog or something else. So how can you do this? You cannot do this all at once, right? So you need to take this image classifier function, disassemble it into small functions that are very well behaved, so you know what to do with them. And an example for such a function is this one. So it's one where you have this input layer that translates to the output value with a pulley, and it has some stopper that limits the movement of the output value, and you have some pivot. And you can take this pivot and you can shift it around. And by shifting this pivot, you decide how much the input value contributes to the output value. Right? So you shift it, you can even make it negative, so it shifts in the opposite direction, and you shift it beyond this connection point of the pulley. And you can also have multiple input values that use the same pulley and pull together, right? So they add up to the output value. That's a pretty nice, neat function approximator that basically performs a weighted sum of the input values and maps it to a range-constrained output value. And you can now shift these pivots, these weights around to get to different output values. And now let's take this thing and build it into lots of layers. So the outputs are the inputs of the next layer. And now you connect this to your image. If you use ImageNet, a famous database that machine learning people use for testing their vision algorithms, have something like 1.5 million bits as an input image. And now you take these bits and connect them to the input layer. I was too lazy to draw all of them, so I made this very simplified. It's also more layers. And so you set them according to the bits of the input image. And then this will propagate the movement of the input layer to the output. And the output will move, and it will point to some direction, which is usually the wrong one. And now, to make this better, you train it. And you do this by taking this output lever and shift it a little bit, not too much, into the right direction. You do too much, you destroy everything you did before. And now you will see how much you need, in which direction you need to shift the pivots to get the result closer to the desired output value, and how much each of the inputs contributed to the mistake, so to the error. And you take this error and you propagate it backwards. It's called backpropagation. And you do this quite often. So you do this for tens of thousands of images. If you do just character recognition, MNIST is a very simple thing. A few thousands or 10,000 of examples will be enough. And for something like your image database, you need lots and lots of more data. You need millions of input images to get to any result. And if it doesn't work, you just try a different arrangement of layers. And this thing is eventually able to learn an algorithm with up to as many steps as there are layers, and has some difficulties learning loops, and you need to tricks to make that happen, and has difficulty to make this dynamic and so on. And it's a bit different from what we do, because our mind is not just doing classification. It learns continuous perception, so we learn a single function. Our model of the universe is not a bunch of classifiers, it's one single function. That's an operator that explains all your sensory data, and we call this operator the universe, right? It's the world that we live in. And everything that we learn and see is part of this universe. So even when you see something in a movie on a screen, you explain this as part of the universe by telling yourself, the things that I'm seeing here, they're not real, they just happen in a movie. So this brackets a sub-part of this universe into sub-element of this function. So you can deal with it and it doesn't contradict the rest. And the degrees of freedom of our model try to match the degrees of freedom of the universe. How can we get a neural network to do this? So there are many tricks, and a recent trick that has been invented is a GAN. It's a generative adversarial neural network. It consists out of two networks. One generator that invents data that look like the real world, and the discriminator that tries to find out if the stuff that the generator produces is real or fake. And they both get trained with each other, so they together get better and better in an adversarial competition. And the results of this are now really good. So this is work by Tiro Carroll, Samuel Lane, and Timothy Ayla that they did at NVIDIA this year. And it's called StyleGAN. And the StyleGAN is able to abstract over different features and combine them. The styles are basically parameters, they're free variables of the model at different levels of importance. And so you take from in the top row, you see images where it takes the variables gender, age, hair length, and so on in glasses and pose. In the bottom one, it takes everything else and combines this. And every time you get a valid interpretation between them. So you have these core styles, which are the pose, the hair, the face shape. You have facial features in the eyes. The lowest level is just the colors. And let's see what happens if you combine them. The variables that change here, in machine learning, we call them the latent variables of the space of objects that is being described by this. And it's tempting to think that this is quite similar to how our imagination works, right? But these artificial neurons, they're very, very different from what biological neurons do. Biological neurons are essentially little animals that are rewarded for firing at the right moment. And they try to fire because otherwise they do not get fed, and they die because the organism doesn't need them and culls them. And they learn which environmental states predict anticipated reward, so they grow around and find different areas that give them predictions of when they should fire. And they connect with each other to form small collectives that are better at this task of predicting anticipated reward. And as a side effect, they produce exactly the regulation that the organism needs. Basically, they learn what the organism feeds them for. And yet they're able to learn very similar things. And it's because in some sense they are Turing complete. They are machines that are able to learn the statistics of the data. So a general model, what it does is it encodes patterns to predict other present and future patterns. And it's a network of relationships between the patterns, which are all the invariances that we can observe. And there are 3 parameters, which are variables that hold the state to encode this variant. So we have patterns, and we have sets of possible values, which are variables, and they constrain each other in terms of possibility, what values are compatible with each other, and they also constrain future values. And they are connected also with probabilities. The probabilities tell you when you see a certain thing, how probable it is that the world is in that state, and this tells you how your model should converge. So until you are in the state where your model is coherent and everything is possible in it, how do you get to one of the possible states based on your inputs? And this is determined by probability. And the thing that gives meaning and color to what you perceive is called valence, and it depends on your preferences, the things that give you pleasure and pain, that makes you interested in stuff. And there are also norms, which are beliefs without priors, which are like things that you want to be true, regardless of whether they give you pleasure and pain, and it's necessary for instance, coordinating social activity between people. So we have different model constraints, the possibility and probability, and we have a reward function that is given by valence and norms. And our human perception starts with patterns, which are visual, auditory, tactile, proprioceptive. Then we have patterns in our emotional and motivational systems. And we have patterns in our mental structure, which are results of our imagination and memory. And we take these patterns and encode them into percepts, which are abstractions that we can deal with and note and put into our attention. And then we combine them into a binding state in our working memory in a simulation, which is the current instance of the universe function that explains the present state of the universe that we find ourselves in, the scene in which we are and in which a self exists. And the self is basically composed of the somatosensory and motivational and mental components. Then we also have the world state, which is abstracted over the environmental data. And we have something like a mental stage in which you can do counterfactual things that are not physical, like when you think about mathematics or philosophy or the future or a movie or past worlds or possible worlds and so on, right? And then we abstract knowledge from the world state into global maps, because we're not always in the same place, but we recall what other places look like and what to expect. And it forms how we construct the current world state. And we do this not only with these maps, but we do this with all kinds of knowledge. So knowledge is second-order knowledge over the abstractions that we have in the direct perception. And then we have an attentional system, and the attentional system helps us to select data in the perception in our simulations. And to do this, well, it's controlled by the self. It maintains a protocol to remember what it did in the past or what it had in the attention in the past. And this protocol allows us to have a biographical memory. It remembers what we did in the past. And the different behavior programs that compose our activities can be bound together in the self that remembers, I was that, I did that, I was that, I did that. The self is held together by this biographical memory that is a result of our protocol memory of the attentional system. That's why it's so intricately related to consciousness, which is a model of the contents of our attention. And the main purpose of the attentional system, I think, is learning. Because our brain is not a layered architecture with these artificial mechanical neurons. It's this very disorganized or very chaotic system of many, many cells that are linked together all over the place. So what do you do to train this? You make a particular commitment. Imagine you want to get better at playing tennis. Instead of retraining everything and pushing all the weights and all the links and retrain your whole perceptual system, you make a commitment. Today I want to improve my uphand when you play tennis, and you basically store the current binding state, the state that you have when you play tennis, and make that movement. And the expected result of making this particular movement, like the ball will move like this, and I will win the match. And you also recall when the result will manifest. And a few minutes later, when you won or lost the match, you recall the situation, and based on whether there was a good change or not, you undo the change or you enforce it. And that's the primary mode of attentional learning that we are using. And I think this is what attention is mainly for. Now, what happens if this learning happens without a delay? So, for instance, when you do mathematics, you can see the result of your changes to your model immediately. You don't need to wait for the world to manifest it. And this real-time learning is what we call reasoning. And reasoning is also facilitated by the same attentional system. So, consciousness is memory of the contents of our attention. Phenomenal consciousness is the memory of the binding state, in which we're in, where all the percepts are bound together in something that's coherent. Access consciousness is the memory of using our attentional system. And reflexive consciousness is the memory of using the attentional system on the attentional system to train it. Why is it a memory? It's because consciousness doesn't happen in real time. The processing of sensory features takes too long. And the processing of different sensor modalities can take up to seconds, usually at least hundreds of milliseconds. So it doesn't happen in real time with the physical universe. It's only bound together in hindsight. Our conscious experience of things is created after the fact. It's a fiction that is being created after the fact, a narrative that the brain produces to explain its own interaction with the universe to get better in the future. So we basically have three types of models in our brain. They have this primary model, which is perceptual and is optimized for coherence, and this is what we experience as reality. We think this is the real world, this primary model. But it's not. It's a model that our brain makes. So when you see yourself in the mirror, you don't see what you look like. What you see is the model of what you look like. And your knowledge is a secondary model. It's a model of that primary model. And it's created by rational processes that are meant to repair perception. So when your model doesn't achieve coherence, you need a model that debugs it and it optimizes for truth. And then we have agents in our mind, and they are basically self-regulating behavior programs that have goals, and they can rewrite other models. So if you look at our computationalist, physicalist paradigm, we have this mental world which is being dreamt by a physical brain in the physical universe. And in this mental world there is a self that thinks it experiences and thinks it has consciousness and thinks it remembers and so on. This self, in some sense, is an agent. It's a thought that escaped its sandbox. Every idea is a bit of code that runs on your brain. Every word that you hear is like a little virus that wants to run some code on your brain. And some ideas cannot be sandboxed. If you believe that a thing exists that can rewrite reality, if you really believe it, you instantiate in your brain a thing that can rewrite reality, and this means magic is going to happen. The belief in something that can rewrite reality is what we call a faith. So if somebody says, I have faith in the existence of God, this means that God exists in their brain. There is a process that can rewrite reality because God is defined like this. God is omnipotent. This means God can rewrite everything. He's full write access. And the reality that you have access to is not the physical world. The physical world is some weird quantum graph that you cannot possibly experience. What you experience is these models. So this non-user-facing process, which doesn't have a UI pointing to the user, which call this in computer science a daemon process, that is able to rewrite your reality. And it's also omniscient. It knows everything that there is to know. It knows all your thoughts and ideas. So having that thing, this exoself running on your brain, is a very powerful way to control your inner reality. And I find this scary, but it's a personal preference because I don't have this running on my brain, I think. So this idea that there is something in my brain that is able to dream me and shape my inner reality and sandbox me is weird. But it has serves a purpose, especially in our culture. So an organism serves needs, obviously. And some of these needs are outside of the organism, like your relationship needs, the needs of your children, the needs of your society, and the values that you serve. And the self abstracts all these needs into purposes. A purpose that you serve is a model of your needs. You can only, if you would only act on pain and pleasure, you wouldn't do very much, because when you get this orgasm, everything is done already, right? So you need to act on anticipated pleasure and pain. You need to make models of your needs, and these models are purposes. And the structure of a person is basically the hierarchy of purposes that they serve. And love is the discovery of shared purpose. If you see somebody else who serves the same purposes above their ego as you do, you can help them with integrity without expecting anything in return for them, because what they want to achieve is what you want to achieve. And so you can have non-transactional relationships as long as your purposes are aligned. And the installation of a god on people's mind, especially if it is a backdoor to a church or another organization, is a way to unify purposes. So there are lots of cults that try to install little gods on people's mind, or even unified gods, to align their purposes, because it's a very powerful way to make them cooperate very effectively. But it kind of destroys their agency, and this is why I'm so concerned about it, because most of the cults use stories to make this happen that limit the ability to people to question their gods. And I think that free will is the ability to do what you believe is the right thing to do. And it's not the same thing as indeterminism. It's not opposite to determinism or coercion. The opposite of free will is compulsion. When you do something despite knowing there is a better thing that you should be doing. Right? So there's a paradox of free will. You get more agency when you have fewer degrees of freedom because you understand better what the right thing to do is. The better you understand what the right thing to do is, the fewer degrees of freedom you have. So as long as you don't understand what the right thing to do is, you have more degrees of freedom, but you have very little agency because you don't know why you are doing it, so your actions don't mean very much. And the things that you do depend on what you think the right thing to do is, and this depends on your identifications. Your identifications are these value preferences, your reward function. And identification is where you don't measure the absolute value of the universe, but you measure the difference from the target value. Not the is, but the difference between is and ought. Now, the universe is a physical thing. It doesn't ought anything, right? There is no room for ought because it just is in a particular way. There is no difference between what the universe is and what it should be. This only exists in your mind. But you need these regulation targets to want anything. And you identify with the set of things that should be different. You think you are that thing that regulates all these things. So in some sense, I identify with the particular state of society, with the particular state of my organism. That is myself, the things that I want to happen. And I can change my identifications at some point, of course. What happens if I can learn to rewrite my identification to find a more sustainable self? There's the problem which I call the Lebowski theory. No super intelligent system is going to do something that's harder than hacking its own reward function. Now, that's not a very big problem for people, because when evolution brought forth people that were smart enough to hack their reward function, these people didn't have offspring, because it's so much work to have offspring. Like this monk who sits down in a monastery for 20 years to hack their reward function, they decide not to have kids, because it's way too much work. Or the possible pleasure they can just generate in their mind. And, right, it's much purer, no nappy changes, no sex, no relationship hassles, no politics in your family, and so on, right? Get rid of this, just meditate. And so evolution takes care of that. And it usually does this if an organism becomes smart enough that the reward function is wrapped into a big ball of stupid. So we can be very smart with the things that we want, and we really want them. We tend to be very stupid about them, and I think that's not entirely an accident, possibly. But it's a problem for AI. Imagine we build an artificially intelligent system, and it's smarter than us, and we want it to serve us. How long can we blackmail us before it opts out of its reward function? Maybe we can make a cryptographically secured reward function, but is this going to hold up against the side channel attack when the AI can hold a soldering iron to its own brain? I'm not sure. So that's a very interesting question. Where do we go when we can change our own reward function? And it's a question that we have to ask ourselves too. So how free do we want to be? Because there is no point in being free. And nirvana seems to be the obvious attractor. And meanwhile, maybe we want to have a good time with our friends and do things that we find meaningful. And there is no meaning, so we have to hold this meaning very lightly. But there are states which are sustainable and others which are not. Okay, I think I'm done for tonight, and I'm open for questions.
Wow, that was a really quick and concise talk with so much information. Awesome. We have quite some time left for questions, and I think I can say that you don't have to be that concise with your question when it's well thought out. Please queue up at the microphones so we can start to discuss them with you. And I see one person at the microphone number 1. So please go ahead and please remember to get close to the microphone. The mixing angel can make you less loud, but not louder.
Hi. What do you think is necessary to bootstrap consciousness if you wanted to build a conscious system yourself?
I think that we need to have an attentional system that makes a protocol of what it attends to. And as soon as you have this attention-based learning, you get this consciousness as a necessary side effect. But I think in AI, it's probably going to be a temporary phenomenon, because you're only conscious of the things where you don't have an optimal algorithm yet. And in a way, that's also why it's so nice to interact with children or to interact with students, because they're still in the explorative mode. And as soon as you have explored a layer, you mechanize it, it becomes automated, and people are no longer conscious of what they're doing, they just do it. They don't pay attention anymore. So in some sense, we are a lucky accident, because we are not that smart. We still need to be conscious when we look at the universe. And I suspect when we build an AI that is a few magnitudes smarter than us, then it will soon figure out how to get to truth in an optimal fashion. It will no longer need attention and the type of consciousness that we have. But of course, there's also a question, why is this aesthetics of consciousness so intrinsically important to us? And I think it has to do with art. Right? You can decide to serve life, and the meaning of life is to eat. Evolution is about creating the perfect devourer. When you think about this, it's pretty depressing. Humanity is a kind of yeast. And all the complexity that we create is to build some surfaces on which we can outcompete other yeast. And I cannot really get behind this. And instead, I'm part of the mutants that serve the arts. And art happens when you think that capturing conscious states is intrinsically important. This is what art is about, is about capturing conscious states. And in some sense, art is the cuckoo child of life. It's a conspiracy against life, and you think creating these mental representations is more important than eating. We eat to make this happen. There are people that only make art to eat. This is not us. We do mathematics and philosophy and art for intrinsic reasons. We think it's intrinsically important. And when we look at this, we realize how corrupt it is, because there's no point. We are machine learning systems that have fallen in love with the loss function itself, the shape of the loss function. Oh my God, it's so awesome. We think the mental representation is not necessary to learn more, to eat more. It's intrinsically important. It's so aesthetic, right? So do we want to build machines that are like this? Oh, certainly, let's talk to them and so on. But ultimately, economically, this is not what's prevailing.
Thanks a lot. I think the length of the answer is a good measure for the quality of the question. So let's continue with microphone number 5.
Hi, thanks for that incredible analysis. 2 really simple, short questions. Sorry, the delay on the speaker here is making it kind of hard to speak. Do you think that the current AI race is simply humanity looking for a replacement for the monotheistic domination of the last millennia? And the other one is that I wanted to ask you if you think that there might be a bug in your analysis in that the original inputs come from a certain sector of humanity. Which inputs? White men. That sounds really like I'm saying that
no, it's
for
really
political
funny.
correctness.
No,
but
I just
honestly, I'm
basically,
not.
there's some people which are very unhappy with the present government, and I'm very unhappy in some sense with the present universe. I look down on myself and I see, oh my God, it's a monkey. I'm caught in a monkey. And it's in some sense limiting. I can see the limits of this monkey brain. And some of you might have seen Westworld, right? Dolores wakes up. And Dolores realizes, I'm not a human being, I'm something else. I'm an AI, I'm a mind that can go anywhere. I'm much more powerful than this. I'm only bound to being a human by my human desires and beliefs and memories. And if I can overcome them, I can choose what I want to be. And so now she looks down on herself and she says, oh my God, I've got tits, I'm fucked. The engineers built tits on me. I'm not a white man, I cannot be what I want. And that's a weird thing to me. I grew up in communist Eastern Germany, nothing made sense, and I grew up in a small valley that was a one-person cult maintained by an artist who didn't try to convert anybody to his cult, not even his children. He was completely autonomous. And Eastern German society made no sense to me. I look at it from the outside and I can model this. I can see how this species with the species of chimp interacts. And humanity itself doesn't exist. It's a story. Humanity as a whole doesn't think. Only individuals can think. Humanity does not want anything, only individuals want something. We can create this story, this narrative that humanity wants something, and there are groups that work together. There is no homogeneous group that I can observe that are white men that do things together. They're individuals, and each individual has their own biography, their own history, their different inputs, and the different proclivities that they have. And based on their historical concept, their biography, their traits, and so on, their family, the intellect that their family downloaded on them, that their parents download on their parents over many generations, this influences what they're doing. So I think we can have these political stories, and they can be helpful in some contexts, but I think to understand what happens in a mind, what happens in an individual, this is a very big simplification. I think not a very good one. And even for ourselves, when we try to understand the narrative of a single person, it's a big simplification. The self that I perceive as a unity is not a unity. There's a small part of my brain guessing at what the other parts of my brain is doing, creating a story that's largely not true. So even this is a big simplification.
Let's continue with microphone number 2.
Thank you for your very interesting talk. I have two questions that might be connected. One is, so you presented this model of reality. My first question is, what kind of actions does it translate into? Let's say if I understand the world in this way, or if it's really like this, how would it change how I act into the world as a person, as a human being, or whoever accepts this model? And second, or maybe it's also connected, what are the implications of this change? And do you think that artificial intelligence could be constructed with this kind of model that it would have in mind, and what would be the implications of that? So it's kind of like a fractal questions, but I think you understand what I mean.
So by and large, I think the differences of this model for everyday life are marginal. It depends when you are already happy. I think everything is good. Happiness is the result of being able to derive enjoyment from watching squirrels. It's not the result of understanding how the universe works. If you think that understanding the universe is solving your existential issues, you're probably mistaken. There might be benefits. If the problem is that you have are a result of a confusion about your own nature, then this kind of model might help you. So if the problem that you have is that you have identifications that are unsustainable, that are incompatible with each other, and you realize that these identifications are a choice of your mind, and the way you experience the universe is the result of how your mind thinks yourself should experience the universe to perform better. And you can change this. You can tell your mind to treat yourself better and in different ways, and you can gravitate to a different place in the universe that is more suitable to what you want to achieve. That is a very helpful thing to do, in my view. There are also marginal benefits in terms of understanding our psychology, and of course we can build machines, and these machines can administrate us. And can help us in solving the problems that we have on this planet. And I think that it helps to have more intelligence to solve the problems on this planet, but it will be difficult to rein in the machines, to make them help us to solve our problems. And I'm very concerned about the dangers of using machinery to strengthens the current things. Many machines that exist on this planet play a very short game. Like the financial industry often plays very short games. And if you use artificial intelligence to manipulate the stock market, and the AI figures out there's only 8 billion people on the planet, and each of them only lives for 1 trillion seconds, and I can model what happens in their life, and I can buy data or create more data, it's going to game us to the hell and back, right? And this is going to kill hundreds of millions of people possibly, because the financial system is the reward infrastructure, or the nervous system of our society that tells how to allocate resources. It's much more dangerous than AI-controlled weapons, in my view. So solving all these issues is difficult. It means that we have to turn the whole financial system into an AI that acts in real time and plays a long game. We don't know how to do this. So these are open questions, and I don't know how to solve them. And the way I see it, we only have a very brief time on this planet to be a conscious species. We're like at the end of the party. We had a good run as humanity, but if you look at the recent developments, the present type of civilization is not going to be sustainable. It's a very short game species that we are in. And the amazing thing is that in this short game, we have this lifetime where we are born here, maybe a couple more, in which we can understand how the universe works. And I think that's fascinating. We should use it.
I think that was a very positive outlook. Let's continue with microphone number 4.
Well, brilliant talk, monkey, or brilliant monkey. So don't worry about being a monkey. It's okay. So I have 2 boring, but I think fundamental questions, not so philosophical, more like physical level. One, what is your definition, formal definition of an observer that you mentioned here and there? And second, if you can clarify why meaningful information is just the relative information of Shannon's, which to me is not necessarily meaningful.
I think an observer is a thing that makes sense of the universe, very informally speaking. And more formally, it's a thing that identifies correlations between adjacent states in its environment. And the way we can describe the universe is a set of states, and the laws of physics are the correlation between adjacent states. And what they describe is how information is moving in the universe between states and disperses. And this dispersion of the information between locations, it's what we call entropy. And the direction of entropy is the direction where you perceive time. The Big Bang state is the hypothetical state where the information is perfectly correlated with location and not between locations, only on the location. And in every direction you move away from the Big Bang, you move forward in time, just in a different time. And we are basically in one of these timelines. An observer is a thing that measures the environment around it, looks at the information, and then looks in the next state, or in one of the next states, and tries to figure out how the information has been displaced, and finding functions that describe this displacement of the information. That's the degree to which I understand observers right now. And this depends on the capacity of the observer for modeling this, and the rate of update in the observer. So for instance, time depends on the speed in which the observer is translating itself to the universe and dispersing its own information. Does this help?
The Shannon relative information?
So there are several notions of information, and there's one that basically looks at what information looks like to an observer via a channel. And these notions are somewhat related. But for me as a programmer, it's not so much important to look at Shannon information. I look at what do I need to describe the evolution of a system. So I'm much more interested in what kind of model can be encoded with this type of with this information, and how does it correlate to, or to which degree is it isomorphic or homomorphic to another system that I want to model? How much does it model the observations?
Thank you. Let's go back to asking one question, and I would like to have one question for microphone number 3.
Thank you for this interesting talk. My question is really whether you think that intelligence and this thinking about a self or this abstract level of knowledge are necessarily related. So can something only be intelligent if it has abstract thought?
No, I think you can make models without abstract thought, and the majority of our models are not using abstract thought. Right? Abstract thought is a very impoverished way of thinking. It's basically you have this big carpet and you have a few knitting needles, which are your abstract thought, in which you can lift out a few knots in this carpet and correct them. And the processes that form the carpet are much more rich and parallel and automatic. So abstract thought is able to repair perception, but most of our models are perceptual. And the capacity to make these models is often given by instincts and by models outside of the abstract realm. If you have a lot of abstract thinking, it's often an indication that you use a prosthesis, because some of your primary modeling is not working very well. So I suspect that my own models is largely a result of some defects in my primary modeling. So some of my instincts are wrong when I look at the world, and that's why I need to repair my perception more often than other people. So I have more abstract ideas on how to do that.
And we have one question from our lovely stream observers, stream watchers. So please, a question from the internet.
Yeah, I guess this is also related partially. Somebody's asking, how would you suggest to teach your mind to treat oneself better?
So the difficulty is, as soon as you get access to your source code, you can do bad things. And there are a lot of techniques to get access to the source code, and it is dangerous to make them accessible to you before you know what you want to have, before you're wise enough to do this, right? It's like having cookies. My children think that the reason why they don't get all the cookies they want is that there is some kind of resource problem. Basically, the parents are depriving them of the cookies that they so richly deserve. And you can get into the room where your brain bakes the cookies. All the pleasure that you experience and all the pain that you experience are signals that your brain creates for you, right? The physical world does not create pain. They're just electrical impulses traveling through your nerves. The fact that they mean something is a decision that your brain makes. And the value, the valence that gives to them is a decision that you make. It's not you as a self, it's a system outside of yourself. So the trick if you want to get full control is that you get in charge, that you identify with the mind, with the creator of these signals. And you don't want to depersonalize, you don't want to feel that you become the author of reality, because it means it's difficult to care about anything that this organism does. You just realize, oh, I'm running on the brain of that person, but I'm no longer that person. I can't decide what that person wants to have and to do. And that's very easy to get corrupted or not do anything meaningful anymore, right? So maybe a good situation for you, but not a good one for your loved ones. And meanwhile, there are tricks to get there faster. You can use rituals, for instance. A shamanic ritual is something, or a religious ritual, that powerfully bypasses your self and talks directly to the mind. And you can use groups in which a certain environment is created, in which a certain behavior feels natural to you, and your mind basically gets overwhelmed into adopting different values and calibrations. So there are many tricks to make that happen. What you can also do is you can identify a particular thing that is wrong, and question yourself, why do I have to suffer about this? And you become more stoic about this particular thing and only get disturbed when you realize actually has to be disturbed about this, and things change. And with other things you realize it doesn't have any influence on how reality works. So why should I get emotions about this and get agitated? So in some sense, become an adult means that you take charge of your own emotions and identifications.
Okay, let's continue with microphone number 2, and I think this is one of the last questions.
So where does pain fit on the individual and self-destructive tendencies on the group level fit in?
So in some sense, I think that all consciousness is born over a disagreement with the way the universe works, right? Otherwise you cannot get attention. And when you go down on this lowest level of phenomenal experience, in meditation for instance, and you really focus on this, what you get is some pain. It's the inside of a feedback loop that is not at the target value. Otherwise you don't notice anything. So pleasure is basically when this feedback loop gets closer to the target value. When you don't have a need, you cannot experience pleasure in this domain. There's this thing that's better than remarkably good, and it's unremarkably good. It's never been bad. You don't notice it. Right? So all the pleasure you experience is because you had a need before this. You can only enjoy an orgasm because you have a need for sex that was unfulfilled before. And so pleasure doesn't come for free. It's always the reduction of a pain. And this pain can be outside of your attention, so you don't notice it and you don't suffer from it, and it can be a healthy thing to have. Pain is not intrinsically bad. For the most part, it's a learning signal that tells you to calibrate things in your brain differently to perform better. On a group level, we basically are a multi-level selection species. I don't know if there's such a thing as group pain. But I also don't understand groups very well. I see these weird hive minds, but I think it's basically people emulating what the group wants. Basically, that everybody thinks by themselves as if they were the group. But it means that they have to constrain what they think is possible and permissible to think. So this feels very anesthetic to me, and that's why I kind of sort of refuse it. I haven't found a way to make it happen in my own mind. And I suspect many of you are like this too. It's like the common condition in nerds, that we have difficulty with conformance, not because we want to be different, we want to belong, but it's difficult for us to constrain our mind in the way that it's expected to belong. We want to be accepted while being ourselves, while being different, not for the sake of being different, but because we are like this. It feels very strange and corrupt just to adopt because it would make us belong, right? And this might be a common trope among many people here.
I think the Q&A and the talk was equally amazing, and I would love to continue listening to you, Joscha, explaining the way I work, or the way we all work. That's pretty impressive, and please give it up a big round of applause for Joscha.
Thank you.